I'm Martha Desmond, here from New Mexico State University, and I'm with the NSF HSI STEM Resource Hub. I co-host this webinar series along with Dr. Delia Baez, who unfortunately can't be here with us today. I would like to welcome you to our second webinar of the fall's webinar series, Targeting Grantsmanship. And today our topic is Multifaceted Transformative Geosciences, NSF support for the interconnectivity of research infrastructure, people, and societal resilience. A little bit of housekeeping before we get going today. This webinar will last approximately 1 hour. Today's webinar has 4 speakers, and we anticipate about 15 to 20 minutes for questions at the end of the presentations. All questions related to today's presentation should go in the question and answer box. Any questions related to Zoom or other technical issues should go into the chat box. Our New Mexico State University team who is here today consists of, well, Delia Baez, Dr. Margie Belia, who's our program manager, Miriam Favela, and Daniel Gonzalez, and myself. And together, this team will be responding to the chat, posting on social media, and curating questions and reading these questions at the end of the presentation. Webinars are also being recorded, and all recordings will be posted on our portal. Please join the network for access to these materials and announcements for these postings, as well as many other benefits. Joining our professional network is free and it's easy. You simply need to go to hsistemhub.org to do this. At the end of today's webinar, you'll receive a short monkey survey from Christine Velez. And we ask that you please take just 2 minutes and fill this out. Some of you have done this for us before. It takes just a few minutes, and your feedback is really critical in terms of reporting to NSF to measure our program outcomes. So thank you in advance for taking a few minutes to do that. And now I want to go ahead and introduce today's speakers. You'll find their complete biographies on our web portal, and in the interest of time, I'm going to shorten those introductions this afternoon. So it gives me great pleasure to warmly welcome our speakers today. First is Madeline Midyette Mann, who is a program analyst with the Directorate of Geosciences at the National Science Foundation. Madeline has been on board with NSF since 2019. Welcome, Madeline. Dr. Lina Patino is with the Directorate of Geosciences at the National Science Foundation. Lina has been with NSF for many years and has served in many capacities. She is a senior program director in the Office of the Assistant Director of Geosciences. At NSF, she has primarily served in with Earth Sciences, where she was division director from 2018 to 2020, and I believe had been with that division since 2005. Dr. Mangala Sharma is a program director for the Space Weather Division of Atmospheric and Geospace Sciences at the National Science Foundation. She has been with NSF since 2014, and prior to this was involved globally with spectrum management and NSF partnerships, teaching at Ohio State University and Pennsylvania State University. Dr. Arnoldo Valle-levinson is a program director in Physical Oceanography, Division of Ocean Sciences with the National Science Foundation. He has been with NSF since January of 2021 on assignment from the University of Florida, where he is a professor in the Civil and Coastal Engineering Department. We are very fortunate to have the 4 of you here today, and we warmly welcome you. So thank you so much. And I'm going to go ahead and turn my video off, and you can get going with your program. Thank you very much.
Thank you, Martha. And thank you very much for the invitation to spend some time with you today. My colleagues and I are happy to share information about the Directorate of Geosciences. Now, the message that we want to leave you with today is that Geosciences is interdisciplinary, and there are multiple points of entry into our discipline. The Director of Geosciences not only supports research, but also the tools and the people needed to do cutting-edge research. And we are also looking to contribute for societal resilience, not only basic research, but also contributing to sustainability of society. Next slide, please. So NSF is an independent agency. It was created by Congress in 1950 to promote the progress of science, advance national health, prosperity and welfare, and secure natural defense. NSF is the only federal agency whose mission is to support all fields of fundamental science and engineering. 90% of NSF's budget is committed to research, education, and related activity. The other 6% is just taken as overhead to pay the operations of the agency. With the funds that Congress appropriates to NSF, we support about 12,000 awards annually. Next slide, please. Now, NSF works mostly with academic institutions, and our organizational structure is similar to that of universities. Think of directorates as colleges. So we have the research directorates of biological sciences, computer and information and engineering sciences, education, human resources, engineering, geosciences, mathematics and physical sciences, and social, behavioral, and economic sciences. In addition to these directorates, there are other parts of NSF that also provide funding. One of them is the Office of Integrated Activities that runs programs like EPSCoR, other programs like Science and Technology Centers. They run programs that are agnostic to the disciplines, basically. And the Office of International Science and Engineering provides support for the US research community to engage in international activities. Now, as of today, the first day of the fiscal year 2022, NSF is looking to the possibility of establishing a new directorate. So maybe by the next time you see a graph like this for NSF, it will be updated. We're going to have the Directorate of Technology, Innovation and Partnerships. And that is the recognition by NSF that we need to support basic research, but in our mission is also to benefit society and to bring those research findings into the market, into the community, and benefit their well-being. So stay tuned for whether we get authorization to create the Directorate of Technology, Innovation and Partnerships, TIP. Now, the infrastructure is not only based on research units that provide funding for basic research, but we have a whole arm of the agency that supports us. So the Division of Budget and Finances, the Office of the General Counsel, the Office of Public and Legislative Affairs. So we are about 1,200 individuals that work at NSF. There will be more on the workforce at NSF later in the presentation. Next slide, please. So following the analogy of NSF and the universities, each directorate is equivalent to a college. And now the colleges are divided into departments, right? So the directorates and NSF are divided into divisions. The Directorate of Geosciences has 5 units that provide funding opportunities. Funding opportunities can be equivalent to the classes that a given department offers. The units within the Directorate of Geosciences are Atmospheric and Geospace Sciences, Earth Sciences, Ocean Sciences, and the Office of Polar Program. And then we have a virtual unit that is for integrated activities and is out of the Office of the Assistant Director. Each unit provides support of a particular area of research including the study of processes in the interior of the Earth, like earthquakes or volcanic eruptions, to studies of the oceans, including biological oceanography, to the atmosphere and beyond. The Directorate of Geosciences supports investigations of processes that take place at different spatial and temporal scales, from the atomic scale to meter to kilometer to global, and processes that take place within seconds to those that have shaped the air over millions of years. Next slide, please. The Directorate of Geosciences supports research based on other natural sciences like physics, chemistry, biology. Now that humans are a major factor affecting the Earth, social sciences are becoming an important partner for geoscientists. Other disciplines like mathematics, engineering, computer sciences provide us with the tools to understand the Earth. In addition, the Directorate of Geosciences supports the infrastructure and instrumentation needed to collect data. These are research stations in polar regions, instrumentations like GPS stations that form networks, research vessels and airplanes, and autonomous floats that collect a wide range of measurements in the ocean. Now, the most important piece, in my opinion, is the support of the next generation of scientists. We do that through programs like GeoPaths, our research experiences for undergraduates, supporting graduate students and postdocs in research grants, and also postdoctoral fellowships. Next slide, please. How to accomplish our mission of providing funding for research, infrastructure, and the human part of the enterprise? The main tool that we use is proposals submitted by the research community from institutions in the United States. The proposals are submitted in response to a particular funding opportunity by a single investigator or by teams of investigators. The funding opportunities are announced as solicitations, program descriptions, or dear colleague letters. Each one of these documents provides details on the goals and what needs to be included in the proposal. It is very important to review these documents carefully. If you have questions, please reach out to individuals identified in the announcement. Contact the program directors for questions of clarifications, not expecting a waiver from the requirements in the announcement, but asking on whether a particular topic is within the purview of that solicitation or communication of funding opportunity. Closing my analogies with universities, program directors are equivalent of professors. Each professor teaches one or many classes. Each program director participates in the management of one or more funding opportunities. A colleague of mine told me when I began at NSF that NSF staff are paid by tax dollars. So don't feel afraid or don't feel intimidated of contacting the program director. We work for you. So give us an email, send us an email, give us a call. We'll be glad to talk to you about specifics of the funding opportunities. Next slide. For the next two sections of the presentation, my colleagues Mangala, Sharma, and Arnoldo, Valle-levinson will highlight two projects that demonstrate how scientists from a wide range of academic backgrounds engage in geosciences research. We hope that even if your area of research is not geosciences, you will see how you can contribute to increase our understanding of our planet. Mangala?
Thank you, Lina. And thank you all for the opportunity to interact with you today. May I have the next slide, please? So let me begin with a question. And I hope you can put your responses into the Q&A. Have you ever seen an aurora? If you have, this is also called the Northern Lights or the Southern Lights. They're really picturesque, aren't they? Well, they're also manifestations of the interactions of our home planet, the Earth, with our nearest and dearest star, the sun. And space weather, too, is such a manifestation of this Sun-Earth system interaction. So solar radiation, energetic particles, magnetic fields, and plasma from the sun interact with the Earth's surface and upper atmosphere. You may have heard of the words ionosphere and magnetosphere. And they create variations in this near-Earth space environment. This happens every day, and we refer to it as space weather. And just like extreme weather, there's extreme space weather. Huge bursts of plasma and magnetic field structures from the sun, called coronal mass ejections, together with sudden bursts of radiation called solar flares, interact with the near-Earth space environment. And such events can create those beautiful auroras and potentially cause electromagnetic damage to critical infrastructure, including the electric grid, satellites, and high-frequency communication systems. So in order to protect these technologies and ultimately the people and society that might be at risk from space weather effects, we need to understand the causes, the origins of space weather, right? And this is where NSF plays a key role. Next slide, please. For several decades now, NSF has been supporting fundamental as well as societally important or use-inspired research on space weather, about the processes in the sun, its plasma and magnetic fields, about Earth's magnetic field, about the solar system, the surface and upper atmosphere of the Earth, including the ionosphere and magnetosphere, and how all of these interactions really affect the human-built environments and critical infrastructure. So we've been supporting ground-based and space-based observational capabilities that study the Sun-Earth system and disturbances in the near-Earth space environment. NSF also supports, as Lina mentioned, data archives, modeling systems, and techniques, including data assimilation and machine learning and AI, that help us understand and therefore predict space weather. And we help build and sustain the pool of expertise required to make and share these discoveries about space weather. Next slide, please. So while it may seem exotic, space weather is truly multifaceted convergent science, and it requires a wide variety of expertise. As you can see, these are some of the researchers in departments supported by NSF who are working on space weather, right? So there are departments ranging from physics, geophysics, atmospheric and environmental sciences, to planetary science and astronomy, to aerospace engineering and computer science who are engaged in space weather. As Lina said, everybody has something to contribute. And indeed, space weather is also a team sport within NSF, right? Multiple NSF divisions and directorates fund space weather research. Next slide, please. So I wanted to give you an example about, about space weather support. So here is a picture of the It Spins CubeSat, right? So it's the ionospheric thermospheric scanning photometer for ion neutral studies. So it's a CubeSat mission, and it consists of CubeSat. So it's a satellite just as big as about, a couple of bread loaves. So imagine a satellite that big, but with very, very sensitive space-grade instrumentation. And this studies the nocturnal ionosphere, which is a layer in the Earth's upper atmosphere. So the It Spins CubeSat was competitively selected by NSF in 2015. And over the past 6 years, with a partnership of Montana State University, Johns Hopkins University, and SRI. The construction has been mainly done by students with guidance of faculty. And ITSPINS was recently deployed into low Earth orbit in just June 2021. And great news is that it has communicated with Earth. So the researchers at Montana State University, are currently performing post-deployment operations and commissioning in preparation for science operations. So NSF is not a space agency, clearly, but why do we support university researchers to build and operate CubeSats? Because it can do unique science. It offers unique research capabilities for space weather studies. And it offers student opportunities, right? So this one-year space mission, for instance, will strengthen a fundamental understanding of the ionosphere and how phenomena such as plasma bubbles or patches in the ionosphere form and evolve, right? So, and it will do unambiguously measurements of the oxygen ion distribution. And that's a very, very important part of understanding space weather. Next slide, please. So in terms of people, right, this is an exceptional opportunity for workforce development. So the educational opportunities that this kind of a CubeSat provides for dozens of students who are going to be the skilled workforce of tomorrow, right? So the ITSPIN team is also offering student and faculty opportunities for partners with the Salish Kootenai College, which is a tribal land-grant community college. So these kind of opportunities to participate in these kind of real-time, science mission planning and operations help advance the diversity in STEM research and education. And societal impacts. Currently, our ability to forecast space weather is in its infancy, just like meteorology was about 50 years ago. So these kind of studies, right, like the ITSPIN's results on ionosphere, help understand and let us better forecast the variations in ionosphere. And therefore, the communications and satellite operators who depend on understanding the ionosphere can better prepare for and increase the resilience, against space weather disruptions. But there's always more to discover. And I like to say that we do space weather research so that a bright flash from the sun doesn't leave us in the dark. So, and as I said, everybody has something to contribute here. With that, let me pass the baton to Arnoldo.
Thank you, Mangala. It's great to be here. Can I have the next slide, please? So my focus, the focus of my presentation will be an outline of climate change. And from this presentation, I feel that it will become evident, as Mangala said repeatedly, and Lina too, that everybody can contribute. So next slide, please. You see some color maps here, that different themes that have been supported by NSF throughout the last decade or so. And you can see that these topics range from educational activities to environmental science, to ocean science, to earth science and the cryosphere, particular aspects related to sea level, to larvae, to hypoxia, to coral ecosystems, to urban environments even. If I can have the next slide. And in terms of departments that have been supported in the last decade related to climate change, you can find a wide range of possibilities to a wide range of departments that have been successful. And they range from atmospheric sciences to oceanography, to marine sciences or oceanography, environmental sciences, geosciences, geology, physics, even environmental engineering and civil engineering too, applied physics. So a good amount of overlap with the space weather topic that Mangala was outlining. If I can have the next slide. So now I'm going to give you an example of a successful project related to climate change. and it's called the Forum for Arctic Modeling and Observational Synthesis. And an important research finding of this project is that record high Arctic freshwater affects the marine environment and the Atlantic Ocean currents, which ultimately affect the climate of the Earth and the local weather around the northeastern continent, Greenland, and even Europe. So this research is focused on the high and very high resolution modeling. By that, it means that it can have a spatial resolution of a few kilometers, the very high resolution modeling at global scales. Can I have the next one? Yeah, in terms of people, this project represents a forum for exchange of ideas and improve the skill of a modeling system that's illustrated on the left portion of this slide, and also to advance the knowledge of the Arctic Ocean. As you can see in the cartoon of the system model on the left-hand side of this slide, you have disciplines required for the model include mathematics, ocean physics, physics of the cryosphere, biology, geochemistry. So there's room for everybody. Lots of different types of models that cover ice, freshwater, ocean, and at different time scales that go from turbulence to decadal variability. And it's designed to go study different processes, again, going from turbulence or mixing to ice reaching convection tides, and its primary productivity in the ocean, ice formation and decay. All of these processes that take place in and around the Arctic Ocean near the North Pole. Very multidisciplinary, transdisciplinary even. Can I have the next one, please? And in terms of infrastructure, this project has created a network of collaborators that is an international network in which it takes the entire planet to resolve local problems in this, or regional problems in this case. So this network will eventually facilitate the understanding of the influence of the Arctic Ocean in the climate and the motion of waters in the ocean. If I can have the next one, please. And finally, the social impacts of this project are quite obvious, because understanding what the role of the Arctic Ocean in the Atlantic Ocean allows better weather predictions, better weather forecasting, and even longer term, better climate forecasting, which can be used for safety of coastal populations in case of hurricanes, or safety of population in case of extreme events, also to forecast fisheries and their health, and also the vulnerability of coastal cities. So the influence of the Arctic Ocean is far-reaching and amazingly broad. And I think that's all I have. And if I have the next slide, please, I just want to reiterate what has been said, that as you can see, there's room for everyone to contribute. So that's it. I pass the baton now to Maddie.
Thanks, Arnoldo, and thanks everyone for giving an overview of the National Science Foundation, the Directorate for Geosciences, and how a multitude of disciplines can contribute to shared global challenges. Even more, it is important to recognize that multi-layered interplay funding has research, infrastructure and facilities, social impacts, and people. So as a short introduction to this portion of the presentation, we will cover multiple ways you can engage with NSF. Options for engagement include the submission of a proposal, becoming a reviewer or an advisor, and exploration of NSF career opportunities. So one of the most obvious ways to engage with NSF is to submit a proposal to a program that is appropriate to the discipline and scope of inquiry you are interested in. So in doing so, you would contribute to the approximately 55,000 proposals NSF receives per year. And of the 55,000 received per year, approximately 11,000 are selected for funding. To explore programs and funding opportunities, you can visit the National Science Foundation's government website and filter proposal submission opportunities by directorate, award type, division, submission acceptances that are NSF-wide and cross-directorate. And other important submission characteristics that you can use to filter include programs that address advancing diversity advancing diversity, among other many filters. So if you're interested in submitting a proposal to the Directorate of Geosciences and contributing to the many programs that advance our knowledge of the world we live in, we encourage you to peruse GEO's programs and envision how you can contribute. We hope you are inspired by the many disciplines and departments that are represented in the Directorate for Geosciences portfolio. We've outlined some funding opportunities here along with their proposal deadlines, and we hope that you're particularly excited about our ability to support postdocs. As you can see with our Earth Sciences, Ocean Sciences, and Polar programs postdoc fellowship opportunities, but please also be aware that some of our core programs have no deadlines, and you can explore those opportunities on our website. So you may also be interested in engaging with NSF as a reviewer or advisor. NSF depends on reviewers and their relevant expertise to evaluate and guide NSF to make wise investments in many fields, including science, engineering, education, and research. Annually, 240,000 reviews are submitted each year. And in addition, NSF is committed to growing and diversifying the reviewer pool to encourage broad input from many different perspectives. Having a diverse set of reviewers is vital to ensuring a more holistic review process and a more meaningful impact on broadening the reaches of science. In addition to providing valuable perspectives and knowledge that best contribute to funding scientific endeavors, reviewers also benefit in multiple ways. Reviewers gain firsthand knowledge of the peer review process, learn more about common problems with proposals, and thus discover strategies for writing stronger proposals themselves. Serving as a reviewer also allows you to network with colleagues from around the nation and NSF program officers. If you're interested, please feel free to reach out to the program officers that manage programs your area of expertise most closely matches. It is most helpful if you introduce yourself, identify your area of expertise, and attach a 2-page CV with your current contact information. We welcome interested reviewers from academia, industry, and the government sector, and we encourage you to share this information with colleagues who may also be interested in being a reviewer. So in addition to gathering input and perspectives through review panels, the National Science Foundation takes input from the community through a committee of visitors and also advisory committees. So committee of visitor panels are formed in regular intervals of 4 years to review programs that recommend or award grants, cooperative agreements, and other contracts that support NSF research and education in STEM. The committee of visitors is composed of external experts, and their mission is to maintain high standards of program management, advise on NSF's performance for continuous improvement, and to ensure that external research and education community is being served by the National Science Foundation. They form recommendations in 2 parts. The first part in an assessment of the quality and integrity of program operations, and the second part, which is program level technical and managerial matters relating to proposal decisions. Advisory committees typically meet twice a year and serve the entire office or directorate to review and provide advice on program management, program balance, and overall program performance. The mission of the advisory committee is to convene a group of external experts to weigh in on program support for research, education, and infrastructure, to facilitate policy deliberations, program development and management, to identify disciplinary needs and areas of opportunity, and to promote openness to the research and education community. If you're interested in recommending an individual for membership, a list of requirements and points of contact can be found on our website. If you're interested in engaging with NSF professionally, career opportunities include management, program, and administrative positions. NSF has 2 career appointees, the director and the deputy director, and this is to ensure that NSF has only limited impacts from presidential transitions. Other management and leadership positions include assistant directors and division directors. And when these positions become available, they are announced on our website. Feel free to review for more information on candidate qualifications. Program positions can be hired in a variety of ways, including a limited term federal employee, a visiting scientist, engineer, and educator, and an IPA, or an Intergovernmental Personnel Act employee. Roughly 33% of program directors are permanent employees, while the rest are hired for a limited term from institutions. An IPA, or an Intergovernmental Personnel Act assignment, may be made to or from other federal agencies, state and local governments, private and public colleges and universities, Indian tribal governments, federally funded research and development centers, and certain qualified nonprofit organizations. Assignments must be made for work of mutual benefit to the organizations involved. Federal temporary appointments are also considered administratively determined appointments and do not require an affiliation with an institution. Appointments are usually up to a year, but may be extended up to 2 years upon agreement between NSF and the appointee. Individuals appointed to the visiting scientist, engineer, and educator program are on a non-paid leave of absence from their institution and typically last up to 1 year. Extensions to this appointment type can be made if NSF, the home institution, and the appointee are in agreement. Science assistants are also a limited term appointment that fall under the program staff classification. And the Science Assistant Program allows individuals transitioning between degrees to work for the National Science Foundation for 2 years to gain federal experience. Administrative positions are vital for smooth operations at the agency, and 2 positions that work closely with funding programs are program analysts and program specialists, both of which are responsible for data analysis, program compliance to federal guidelines, and many other responsibilities that fall under panel support. The Pathway Program is another way the National Science Foundation engages students, offering work experience in the federal government through an internship program. In addition to the positions I've outlined here, the National Science Foundation has positions open for applicants who have degrees and pertinent experience in law, communications, design, and public relations. If you're interested in learning more about these positions, the criteria for hire, and current job openings at NSF, feel free to visit our website. Thank you all for your attention today. Before we take questions, we would like to bring your attention to some resources we have listed here. Please note that these websites are connected to our main page, nsf.gov, and they will link you to different portions of the website as you see fit. Please feel free to follow us on social media if you have not already done so. And if you have any questions at a later date, please don't hesitate to reach out.
So thank you all for taking the time to join us today. We greatly appreciate it.